Assalamualaikum warahmatullahi wabarakatuh. My name is Asmadi. I'm from Situ University. Today I will present about preliminary experiment of Saccharomyces cerevisiae Immobilization using method of in situ flocculation. Introduction. Ethanol, an organic compound, is an important chemical in industrial application. This is solvent, disinfectant, or antiseptic, intermediate chemical, and renewable energy sources. During the coronavirus pandemic, the demand for alcohol has increased, and therefore the price has also increased. This can be overcome by increasing productivity, so that the demand for alcohol can be met. Productivity can be increased by continuous process or cell immobilization method. Inoculum development. The inoculum was developed in two steps. This is inoculum 1 and inoculum 2. Inoculum 1 was developed by inoculating 1 OC Saccharomyces cerevisiae into 100 ml medium. Medium made from this extract, peptone, and glucose. Inoculum 2. Inoculum 2 was developed by 10% volume for volume of inoculum 1 into 1000 ml medium. Medium made from sucrose, glucose, yeast extract, ammonium chloride, magnesium sulfate heptahydrate, and calcium chloride dihydrate. Experimental testing of cell growth. 100 ml medium sterile made from sucrose with different concentration of 2%, 3%, and 4% weight per volume. Then added 10 ml of inoculum 2 and incubated in a shaker incubator at 50 degrees Celsius and rotation speed 125 rpm for 48 hours. And then sampling. Sampling was carried out periodically every 5 hours for calculation of cell population using a mass cytometer. In situ flocculation. In situ flocculation, there are two steps. This is startup process or batch process and flocculation process. The in situ flocculation process uses an integrated aerobic anaerobic buffer reactor with a capacity of 10 liters. The reactor was divided into two compartments of A and B. This is unit of integrated aerobic anaerobic buffer reactor with the equipment aerator, agitator, and recycling pump. Startup process or batch process. 9000 ml medium made from sucrose, 2% wafer volume was filled into the reactor and distributed into compartment of A and B. Then added 1000 ml of inoculum 2. And recycling to distributed sucrose medium and inoculum homogeneously into compartment of A and B. Flocculation process. 100 ml flocculant solution was added to compartment B and agitated shortly at 200 rpm. The flocculant would be dissolved homogeneously and the agitation stopped for 24 hours. The flocculant solution made from polyacrylamide anionic. Cell and discussion. Cell grow in various sucrose concentration. From this graphic, we can know sucrose medium of 2% and 3% is more favorable medium for the yeast growth. It grow to reach 7.4 multiplied by 10 to the power of 7. Temperature and pH during fermentation process. From this graphic, we can know the incubation temperature are relatively constant. It starts from 29.6 degrees Celsius and increase to 32.2 degrees Celsius at the end of the startup process of 30-hour fermentation. When in situ flocculation starts from the 30 hours of fermentation, the temperature moves down to 30.1 degrees Celsius at 54 hours of fermentation. Meanwhile, it finds out that the pH medium for piles moves down from 4.6 to 4.2 between the initiation of fermentation and the end of process. Cell population during fermentation process. Cell population reaches 1.03 multiplied by 10 to the power of 8 cell per milliliter at the 30 hour of fermentation, and it is the initiation time for the in situ flocculation. The effect of flocculant is the cell population coming down from time to time due to the yeast cell entrapped in floc and immobilized. It indicates the flocculation process is going on. The cell population in compartment A decrease between initial flocculation and the next 12 hour of incubation, then grow up to 54 hour of fermentation process. Different phenomena of cell population happen in compartment D. The cells are still calmed down into 7.70 multiplied by 10 to the power of 6 cell per milliliter at 54 hour of fermentation and start to grow due to the sucrose feeding. This different phenomena is predicated by that the aeration process done in compartment A. Residual sugar in the fermentation process. Profile of residual sugar will be associated with the profile of cell growth. From this graphic, we can know the residual sugar always tend to decrease until 54 hours of fermentation, which is no feeding medium while the consumption is still going on. The feeding medium is started at 54 hours after inoculation, where the residual sugar start to increase as well as Saccharomyces cerevisiae also increase in the related time. This phenomenon explains that sucrose feeding rate is higher than the consumption. Ethanol concentration during fermentation process. Ethanol is a primary metabolite which is synthesized by yeast while the growth phase is going on. From this graphic, we can know ethanol concentration was grow up as well as the yeast population grow, while ethanol concentration also decrease when yeast population decrease. The flocculated yeast cell have infinite activity in producing ethanol and need time to adapt the condition. The highest ethanol concentration obtained during the fermentation time is 4.85% and it occurs at 42 hours of fermentation. Conclusion 1. The in situ flocculation was initiated at a cell population of 1.03 multiplied by 10 to the power of 8 cell per milliliter and caused the free cell or untrapped cell population moving down to 7.70 multiplied by 10 to the power of 6 cell per milliliter during 24 hours of process. 2. The free cell population grew up when feeding sucrose medium fluid with a flow rate of 500 milliliter per hour and reached 2.32 multiplied by 10 to the power of 7 cell per milliliter at 18 hours later. 3. The highest ethanol concentration of 4.85% was obtained from this fermentation process. Thank you.